Okay, welcome students. Okay, so some further notations, some more notations to learn. Okay. First, I think you understand this symbol already. What does this mean? Somebody? What's that symbol?
Set
Of
X.
Good. The set of X values, right?
Yeah.
Yep. Then?
Such that
Yep.
the element of X.
No.
Oh,
You can say element of, yeah? Not a very good guess. You can say real number, it's got to look like an R. Okay, integer or integers. These are used often to express domain and range shorthand. Okay? For example, if I say x is less than or equal to 1, greater than minus 2, this is equivalent of saying minus 2, you call this a bracket or you call this parentheses?
parentheses. I don't know. Okay. I think you call them the same thing.
One's a bracket, one's a parentheses apparently. I get them confused all the time. I'm not going to use any name. I believe this is called the bracket and this is called the parentheses.
Yeah.
Okay, you notice here when it's when it's greater than or equal, just greater than, you use a round bracket. When it's equal to, you use a square bracket. Or if I want to say minus 3 is less than y is less than 4, what would that be equivalent to?
Parentheses, -3, comma, 4, and then closing parentheses.
Yeah. Is that clear?
Yeah.
So they can have notations like that. That will cover this idea here. Point number, understand? What's that symbol?
Infinity.
Right. Okay, so what is a locus, firstly? So this is now where I'm just going to give you some definition, which you will need. You need now. You need to know now, in fact. You can actually learn locus in year 9 or year 10. Anybody ever heard of the word locus?
Something.
It is a set of points. Yeah? That satisfy some given condition. See if you understand what I'm trying to say. When you talk about a set of points, it's like this. Do you agree or not?
Yeah.
Yeah.
That satisfies some given condition. What does that mean? Such that. I use the word such that, you know what I mean? Because it set of points that satisfy. So that can be abbreviated to such that. Do you agree?
Mm-hmm.
Yes.
Not abbreviated, but using a different phrase. So a set of points such that it satisfies some given condition. What do you mean by a condition? For example, I can describe the condition in words, or I can describe it in functions and relations. Right? So for example, set of points such that they are 2 units from C, which is 1, 1. N. You understand what I just wrote? Let's visualize that. All right, because when you talk about points, the first thing you should do is draw up your Cartesian plane. Do you agree?
Yeah.
Now, we want a set of points that there are 2 units from the point C, which is 1, 1. So if I if I locate the point C like that, that's 1, 1. How do I find these sets of points which satisfy this condition? So this is the condition here. What do you think it looked like when if you move the set of points? What do you think it looked like if you find and locate all the points?
Circle.
Such that
They're 2 units from C.
good. So I go 2 units away. All those points, if I call it x, y, let the variable points that can move on the locus be called p. Then if I move it, I should actually get a circle. Wherever it is, its distance is always 2 units. So that distance becomes the radius of a circle. Is that clear?
Yes.
Yeah.
So
Yeah.
qualitatively, the locus is a circle centered where? Are you clear?
Yes.
Okay. Can you see now there's 2 descriptor of its locus, 1 here and 2 here. That's the 2 qualitative descriptor of this locus. You can say there are set of points x, y such that there are 2 units from C 1, 1. And if you can actually find out what the geometrical shape look like, which is a circle, you can say, well, it's a set of points such that they lie on a circle center at C 1, 1 of radius 2 units. Are you clear?
Yeah.
So you can pick all the circles, pick all the points in the circle, and you drop into this set, then it will contain all the points. So let's now quickly look at how we can describe this quantitatively. Is again, I can approach it differently. I put C here, 1, 1 here, and then wherever, I'm going to let, sorry, I skipped a step. I'm going to let P, the point P, x, y, be a variable point moving along the locus. So I don't know. Let's just not assume that we know that it's a circle for now, right? Let P be any point that can move along the locus. So here's P. I'm just placing it anywhere, right? If you read the condition you get of the locus, what does it say?
Yes.
Yes.
That's quantitative, isn't it, right? I'm translating the condition into a quantitative way of measure. How do you get PC? Quantitatively.
Pythagoras.
Or that's the distance of PC, and that should equal 2, isn't it right?
Mm-hmm.
Yep.
Now finish that off, please. Substitute it in. What you should have is x minus 1 squared plus. You agree?
Yeah.
Yes.
And I will stop right here because this is, if you don't recognize it, this is a general equation of a circle, implying a locus. Now we identify what it is, and we can say a circle centered, all right, C, H, comma, K, and radius equal to R. Me or email me.
Okay.
Enjoy it.
Thank you.
Have a good dinner. All right.
Thank you, sir.
Thank
Thank you, sir.
you.